Hello, Mr. Kaladi here. Today I'm going to be showing how to use a logarithmic scale to represent exponential data in a chart. And I'm going to be doing this by using the COVID-19 pandemic data for Italy and Canada. You'll also notice that I'm using Microsoft Excel to show this, to demonstrate this, but you could just as easily use Google Sheets, which has the same functionality, or any other piece of spreadsheet software. Just so you know, the data I'm using is public domain data. I picked up the data from Wikipedia. Here is, for Italy, the number of cases, of COVID cases. Someone's actually gone through a lot of effort to list all, for each region, the number of cases. This is each region of Italy. I was really only interested in the number of new confirmed cases per day. Similarly, here's the Canadian data. We're looking at the number of cases for every province of Canada. I was really only interested in this column here, the number of new cases per day, and they have the data for every day kind of the pandemic. Basically what I did is I copied this entire table into a spreadsheet and I extracted the columns that I was interested in. Maybe showing that extraction of data from this table is another YouTube video. For now though, I want you to at least be able to appreciate where these numbers come from. So what I've done is I've taken, here's the Italian COVID-19 data, and I've called day 1 to be the 20th day, or sorry, I called day 1 to be the day that we had 20 confirmed cases in Italy. So that was actually February 21st, 2020. This is at the very beginning of the pandemic. Most countries didn't even know it was happening or didn't even know that COVID-19 was in their country yet. So that's why we use 20 confirmed cases as a way of kind of counting when people were properly keeping track. So this is a number of cases. This is day 1, day 2, day 3, and this is the number of new cases per day. So for example, on February 21st, there were 20 confirmed cases at least, and then we had 17 new cases that day. The next day, February 22nd, we had 59 new cases. And so you can see the exponential growth happening in that data. Canada, by contrast, lagged Italy a little bit. We didn't have 20 confirmed cases until a week later, February 29th, but we call that day 1. This way, we can compare the growth rates in both countries. And they're both starting, day 1 is always 20 cases. So I'm going to graph the Italian data. I'm going to select all of my data, click and drag. I have 40 days worth of data. And then I'm going to go to Insert and click on the little scatter plot. Now we're never going to use any of these other options where the points are connected or there are smooth lines. If you're ever analyzing data in math or science class, you should just plot the dots because those are the discrete points that you know. And Excel will generate a nice chart. You can see that it automatically interprets the first column to be the X values and the second column to be the Y values. I don't like how it seems to forget to include used to include the axis automatically. I can go to Chart Design, Add Chart Element, and insert an axis title. We need a horizontal title. It should be days after 20 confirmed cases. And similarly, I'm going to add a axis title, primary vertical. That should be number of new cases per day. Perfect. Oops. And this is, oops, Italy COVID-19 data. Okay, so you can get a sense that this is exponential growth. I mean, we know it's a pandemic, and we know that virus reproduction is exponential, but you can see kind of the shape of it, right? It starts off, it's basically nothing for the first 10 days, and then it shoots up very quickly in that exponential growth. It actually starts to drop off a little bit in the latter half of the data, but that reaches up to 7,000 very, very, very quickly. Let's contrast this with Canada. I'm going to select all the data over here in the Canadian tab, and I'm going to insert a scatter plot. Similarly, I'm going to call this the Canada COVID-19 data, and again, I'm going to insert axis title primary horizontal. So this is going to be days after 20 confirmed cases. And I'm going to also add axis title primary vertical number of confirmed cases. Oh, number of new cases. Uh-oh, did I do this right? Number of new cases per day. Okay, so you can see Canada as well, nothing is really happening the first 10, even 15 days, and then we get this really rapid exponential growth. Not as many, it doesn't get quite as high, but you can see it does grow fast. So the thing is, when you look at these two charts, it's hard to determine which country has COVID growing faster. I mean, obviously, Italy has more cases. But in terms of the growth rate, it's really hard to get a sense because the exponential growth an exponential data, it's kind of useless at representing data. Like at the beginning here, you can't really learn much, and the scale is so skewed because the numbers get so high. So one way to alleviate this when you're dealing with exponential data is to use the log of your y values. It's a log scale, we call it. So one way of showing this is I'm going to write, I'm going to make a new column in my spreadsheet. This is with the Italy data. I'm going to call it log of the number of new cases per day. And that's going to be wrapped like that. So, okay. So what I'll do here is I'll type equals to show that I'm entering a formula, and I'll type log, open bracket, and this is going to take, and then I'm going to click on the number of new cases. So now I'm going to take the log of that number. So essentially what I've done is and it's a log base 10 obviously because I didn't specify base. Remember, the whole idea of logs were invented or developed was to help add and subtract, to help multiply and divide large numbers. So the log essentially takes this large number and kicks it down to a small number, the exponent that I would raise 10 to in order to get 17, right? 10 to the power of 1.23 is 17. I'm going to copy this formula, and now if you hold Shift and click down, I'm going to select all these other cells, and I'm going to press paste or Control V, and now I've pasted that formula log of this other cell into each of these squares in the spreadsheet. So you can see Excel is kind of smart. I say log, it automatically knows that in this cell I want the log of this number because I've copied the formula. It's always taking the log of the number to the left of it. And you can see I have all these logs now. Again, what is a log? Well, if we go down to the last number, 3. So if I took 10 to the power of 3.6, that would give me 4,053. So essentially I'm writing the exponent. Now, why do we care about this? Well, watch what happens now when I graph this data. There's a few ways of graphing it. What I could do is I could select I need this as my x values. The days need to be my x values. Now, if I hold the Control button and select the third column, now I've selected the x and the y values I'm going to use, and I can click Insert Scatter Plot once again, and now we've graphed the same data but with the log scale. So again, this is annoying, but I'm going to add the axis titles. So this is the days after 20 confirmed cases, and I'm going to add axis title primary vertical. This is the log number of new cases per day, and this is still the Italy COVID-19 data log scale. Okay, so now let's look at this. Now I still have the x value, still going up day by day, but now I'm looking at the logs, the exponent of my data, and you can see now I can see the rate of change. Essentially, I've taken what's exponential data and I've represented it in now what looks like a linear form. So I can see that the slope of the data is actually is actually fairly steep at first, but then the slope of the increase, or the rate of increase, decreases as my days get on. You can see that by day 30, Italy has kind of flattened the curve in that the new cases per day is leveling out. You might not have gotten that if you were looking at this data. You might not have been able to discern the same kind of conclusion because it's such a steep scale. This is especially neat if I want to compare to Canada, if I want to compare two countries. I'll show you a different way to do this with Excel. If I click on the new cases per day, if I click on series options, if I click on the Y values and click Format Axes, I'll get a bunch of options here. I can change my, where I put the tick marks, how they look, but I could just click logarithmic scale, and then boom. Excel automatically knows what I'm asking, because asking for a logarithmic scale is a very common thing when you're analyzing exponential functions. So this, I didn't do a log scale on the X, just the Y. And now you can see that the numbers go up by like times 10. That's kind of the characteristic of a log scale. And remember, when we found all these numbers before, they were all pretty low values. Now you can get a sense of the number of new cases per day for Canada and the rate of increase. So if I compare Canada and Italy, can I copy this chart? Maybe I can copy it to this other. Oh, no, I can't do that. Let's not do that. But you can look at Canada and see that actually the slope of this line, the rate of increase, was higher in Canada, right? It's a little bit shallower in Italy. More people were getting sick, but the rate of increase wasn't as fast as Canada. It has a steeper increase in Canada, although again, it does level off later on around day 35, 40 as we began to implement restrictions. This was one thing I was following during the pandemic. It wasn't useful to look at the exponential growth like this. It's too difficult to discern information. But if you looked at every country on a log scale, you could then compare the different countries. Again, you were comparing linear slopes, and you could say, oh, well, this is less steep than Canada's, so Italy actually has a slower growth rate. So hopefully you're able to use a log scale in the future to help represent data. Good luck with that, and we'll see you next time.